Welcome everyone. Thanks for joining us today. I'm Juan. I'm a backend engineer here at Grace. I'd like to start out by thanking the ClickHouse people for organizing the meetup. Thank you all for coming. And here at Grace, we're pretty big fans of ClickHouse. We've been using it for almost 6 years now. And today we're going to be talking about some of the ways we use ClickHouse. So just to start us off with the agenda, I'll talk about who we are, what our mission statement is. Then I'll sort of set up the architecture overview so you guys understand how we use ClickHouse, and then I'll segue into how we use particular projections, which is pretty nifty. And then at the end, we'll have a Q&A time. So the problem that we're trying to solve with Grace is that whenever you code an app on your phone, you're always going to get in the ideal condition. So it's plugged in, you got the latest iPhone, internet connectivity, everything's great. And then you put your app in the wild and things start breaking because people are on older devices, older operating systems, they're not plugged in, their network connectivity is shit. So, inevitably you'll get the call that something's broken. And you have a really hard time telling whether or not it's a real systematic problem or if it's, just a one-off that somebody's having. So the idea is that we collect the information on your app to make sure that it's behaving properly, and then we can tell you whether the issues that your customers are having are, again, one-offs or just some emblematic of something bigger. So with that out of the way, what we are is that we're a modern mobile app observability tool. We're built on the open telemetry standard, and we're really focused on apps performance so that people can see what you're seeing in the real world. What we do is that we don't sample any data. We're able to collect all the user sessions and all the events that are happening on the customer's device. And from there, we're able to aggregate into insights. And since we have all the data, we're able to dig down into individual user sessions and see how you've gotten to that issue. So you might have a really prevalent crash, and then when you dig into it, it turns out that when you see it in context, people are doing some kind of bad thing in their code and they're in. So again, you're able to start from high-level insights, and then you dig down into the user sessions to really see what's going on. The other nice thing is that since we're built on open telemetry, we integrate really well with your backend stack. So we're providing the missing half of seeing what your customers are seeing on their apps, but then you can see it side by side with what you're seeing on your backend. So your backend will be reporting, I'm having, everything's looking fine, able to serve up images or do the business logic, and then you can see actually my user's having a connectivity issue, which is why they're crashing. That's what we do. So this is a pretty standard data ingestion pipeline. We have our SDK in the mobile device, and that's just sending us a bunch of data. We collect roughly a few billion sessions a month, and each of those has hundreds of events possibly. So we send it out to the backend, and our backend is right there to ClickHouse. And as I previously mentioned, people see high-level insights, but then we're able to dig down into the specifics, again, because we don't do sampling. And this means that we need a tool that's able to handle a lot of data, and ClickHouse is such a tool that we can handle all of it. And if you guys have used ClickHouse before, a very common pattern is that you have your base table. This is just a toy example for clarity. But we'll have an events table where we're getting all the things that are coming into our system. And you can also have a materialized view. It's a separate optimized table that can answer a query, a different query, much faster. So in the first case, we have an events table that can answer any and all things related to events. And that will shorten it, maybe it's a few weeks because it's literally one row is every single event. But you can optimize queries, let's say, break down app adoption by country by having a table that's highly aggregated, and this one can work for a really long time. And that's actually been historically the way you optimize your queries in ClickHouse. If something needs to be faster, create a better order by key, or aggregate your data more. And this was going on fine. We were able to get this to work for us, but the way that we make materialized views, first you gotta play around with the schema, you have to create the table, and then you got to backfill it, which is a big pain. And we found that this process was easing up a lot of our developer time. And we heard about these things called projections, which seem to be a really good alternative to this approach. And now I'm going to talk about projections and why we like them so much here at Voice. All right. First off, projections are relatively new. They were introduced in 21.8, very experimental, of course, as a lot of things in ClickHouse. And then they were declared stable in 22.3. So we were already using materialized views from before, and then projections came after. And what a projection is you say on this table, I want to create a separate hidden secret table that reorganizes the data with a different order by key so that you can read out the columns or the aggregated data more efficiently for a particular query. And the thing that's really cool about projections is that all of that is hidden. Back here, I had an example where the reader needed to be aware that if I want to hit the events table, here it is, and if I want something optimized by country, I have to remember to hit the events by country table. But the nice thing about projections is that once you attach them, your readers don't care. You just query that same table, and ClickHouse will intelligently pick the right optimized table for you. So just to give you guys some pros and cons, again, the really cool thing is that a projection will abstract away the existence of these optimized tables, and this makes it so that it's really easy to deploy new features and optimize your queries because there's no code changes, there's no deployments. All you need to do is write some SQL and you're done. Like I said, they're easy to create. They're also super easy to backfill. Again, with materialized views, you have a separate table. You have to start to have all the previous data, start crunching it and go backwards in time. That is not an issue. In fact, I would say that when we were working on materialized views, backfilling actually took the longest period of time. So projections just copy instead. The nice thing about projections too is that you can actually have more than one projection per table. And you can even throw them on aggregated tables. So they're very flexible with a lot of stuff you can do. But they do have their costs. That data has to be stored somewhere. Again, I said that they have some kind of hidden table, and you're going to incur some storage costs. And then the other thing is that as it's organizing data into the projection, you are going to have some I/O and CPU overhead just because it's doing more things at the same time. But just sort of skim over the detail just because it's not super important here. And the last thing I will say about projections is that because they're a bit magical, it won't always be intuitive which projection you're using because you've abstracted it away. I just hit this table and then it'll just pick the right one for me. So it could be a little bit tricky to debug. Right. So now I'm going to be talking about a concrete example just so that we guys can see it in action. So we had a page that was loading slowly, and it turned out that we had a suboptimal order by key in our traces page. So we deployed this feature, it was working really well, and then a large customer started adopting it, and for their particular use case, our order by key was not working as well. So rather than doing the whole materialized view approach, we decided that we'll try projections instead. This is, again, a simplified version of what we did, but basically we said, all right, if we need to create a list of our traces and give information about how many there are and the quantile state, we'll throw those columns in there with a view order by key so that you see that it's optimized for the app version and then the name of the trace. And it turns out that just after running this and materializing it, for free, we got a 2x performance gain. This is pretty cool. Again, no developer time, no really not a whole lot of infrastructure costs. All you needed was to write some SQL, materialize it, and you were done. There you go. This is already pretty exciting. And just as an aside, one of the ways that you can tell that you're using a projection is that if you run explain on the query that you're trying to optimize, you should see that here in the AST, it is reading from the projection that you were writing and not your base data. You can see that it's leveraging it. And that sort of goes back to what I said about maybe it's not clear exactly what table is being used under. So now I'm going to talk about some gotchas and the ways that we improve the usage of projections and sort of give you some real world examples of how you can improve them. The first problem that we ran into is that we optimized a single query, but the rest of the queries were slow. And again, we did our debugging, and it turns out that all the other queries were not able to leverage the projection because they were not in the order by key. I said, hey, if you want to use this projection, here are all the columns that you care about. Again, I want a list of all of my traces. But as soon as somebody said, I want to know what's happening with my users in the UK, that's on the projection, it's not being used. And the way you solve that is that you rewrite your projection and you throw in all the columns that you want to pick out, and now the projection can be used instead. So if you add more columns, you do increase the storage costs, you do increase some of the CPU overhead that I mentioned earlier, but when we apply this, we still had very similar gains, about a 2x increase, and we were not able to distribute it for all our similar queries. The other problem that we ran into is that a lot of the aggregate queries were still slow, and it turns out that projections can do one or two things. They can either reorganize the data by changing the order by key, or they can also pre-aggregate data for you, much the same way that materialize you can. So this is very similar to what we had before, but rather than storing the columns, we were saying, all right, I want to store the sum, I want to store the quantile state, so all this stuff should be aggregated. And again, I'm still referencing that same table. I don't need to remember that there's some magic aggregated table down there, just talk to spans. And after we applied that, we had a 10x performance gain. Again, very little developer time. We didn't need to worry about backfilling this table. It was all very fast. Deploying projections is quite easy. The way you do it is that you just run materialized projections, and it will run asynchronously in the background. And if you're worried that this is going to be very slow or it's going to otherwise put too much load in your server, you can also do it piecemeal. And what we do sometimes is we say, hey, materialize in today, we partition our data daily, and then we go backwards in time. Okay, materialize today, yesterday, the day before. Much easier than trying to backfill data and so materialize. And again, the way this is able to work is that this is what the table looks like externally, and we have 3 sets of data. The actual data that we're writing to the table, and then the 2 projections that we wrote. Some other way of reorganizing the data so that some queries can be optimized. And the really neat thing is that ClickHouse will just pick which of those inner hidden tables is best. So that same query could go in, and rather than doing the inefficient lookup at the traces table, it was able to completely aggregate, and that's where we were able to get that really nifty 10x increase. So again, just to summarize, the reason projections are so cool is that we're able to get massive performance gains without changing our queries, without changing our code. We're able to do it with very minimal developer time, so other people can go on and build really cool features instead of optimizing our queries. And they're super easy to deploy. And it turns out that for this example that we've been looking at, we got about anywhere from a 2 to a 10x increase, and we only incurred a 20% storage cost, which I'll happily take that trade. I'd like to give special thanks to Sati Leda. He was actually the one that did all the experimenting and the work on the projection. So unfortunately, he wasn't able to be here to present his work, but he's the real mastermind behind all the cool things.